Auzubillahiminash-shaytanir-rajeem. Bismillahir-rahmanir-rahim. Dear students, Assalamu alaikum. So today, class 10, subject physics, chapter number 13 we are doing, and the name of the chapter is electrostatics. Topic of today's lectures will be 13.3, which is topic of today's lecture will be 13.3 and 13.4. Pages covered 71, 72, 73, and 74. We will try to cover these pages. I repeat, class 10, subject physics, chapter number 13. We have just started, and the topic, name of the chapter is electrostatics. Topic of today's lecture will be 13.3, which is electroscope, and 13.4 will be Coulomb's law. Okay, we will try to cover these two topics, and pages we will cover 71. Electroscope is on 71 page, and then we'll keep on going 72, 73, 74. So this is the chapter we are doing, unit 13, electrostatics. The name of the chapter is electrostatics. And today's topic will be electroscope 13.3. I repeat, 13.3 electroscope. Then today's topic is electroscope, and on page number 71. Please open page number 71 of 10 class textbook. Today we are going to start 13.3 electroscope. You should be very clear what we are doing. Okay, 13.3 electroscope on page number 71. Please open it. So first of all, I make you familiarize with the figure, and the figure is 13.6. Now, what is electroscope? Electroscope, this is called gold leaf electroscope. Gold leaf electroscope is a sensitive instrument for detecting charge. This electroscope we use for detection of the charges. In order to, for the detection of the charges, we use electroscope, and that is called gold leaf electroscope. Is an sensitive instrument for detecting charges. What it consists of, it has a, on the top, we have a brass disc. This is the brass disc, okay? And then we have brass rod. This is the long tube which is coming out of from brass disc. It is called the brass rod. You can see, you can't see over here, but you can see on your textbook, okay? And the next one is leaves. These are the few leaves, the two leaves underneath the rods, okay? And then you have ground over here, and it is aluminum foil, and it's the insulator over here. Why we place insulator over here? To keep the rod straight, to keep the rod in position. We use the insulator. Okay, I repeat, this is electroscope, and gold leaf electroscope is an insensitive instrument for detecting charges. This is used for detecting charges, whether the charges are there or not, whether there are the charges or not. So for detecting charges, we use the gold leaf instrument, which is a sensitive instrument for detecting charges. It consists of brass disc. You should be very clear about where is brass disc, what is the function of brass disc, what is the brass rod, and what is leaves. These three things are very important: disc, brass disc, and brass rod, and leaves. These three, leaves and brass disc, are very important. Brass disc and leaves. Okay. So I will explain you in a bit what is the function of brass disc and what is the function of leaves. Okay. And these two leaves are attached with the brass rod. And this brass rod is, and insulator is used to keep the brass rod straight. Okay, we have grounded this over here. This is also the function I will explain you. Um, Gold leaf electroscope is a positive, sensitive instrument for detecting charges. It consists of brass rod with a brass disc, I told you, at the top, and the two thin leaves of gold leaves. These are the gold foil leaves, okay? Hanging at the bottom. They are hanging at the bottom. These are the gold leaves. They are hanging at the bottom. The whole the whole assembly is fitted in a glass, and this all things are placed in a glass. They are fitted in a glass. Okay. Charges can move freely from the disk to the leaf, from disk to the leaves. The charges can move freely from disk here. The charges move from here to the leaves. A thin aluminum foil is attached on the lower position of the inside the charge. Usually, aluminum foil is grounded by the disconnecting the copper wire. So this has been grounded. This has been aluminum foil has been grounded. This protects the leaves from the external electrical disturbance. If there is an external electrical disturbance, this ground will protect it. Okay. So now I told you detecting the gold leaf electroscope is used to for the detection of the charges. First of all, this is the neutral body. Figure 13.7 is the neutral body. Okay. In order to detect the presence of charge on a body, bring the body near the disk of an uncharged electroscope. This is uncharged electroscope because there is no charge on the electroscope. We haven't brought this rod till here. It is just a line, and electroscope is just line. It means there is no charge on it. So it is a neutral charge. There will be no deflection of leaves because there is no charge on the electroscope. There will be no deflection. The leaves will not diverge, or the leaves will not converge or diverge because there is no charge on the disk. But if the body is positively and negatively charged, the leaves of the electroscope will diverge. If it is a positively charged or negatively charged, the leaves of the electroscope will diverge. For example, if the body is negatively charged, then due to the electrostatic induction, positive charge will appear on the disk, while negative charge will appear on the leaves. Okay, I explained you in my earlier lecture the conduction, the process of conduction in my earlier lecture, how the when we bring the rod near to the two metal spheres. So if the rod is positively, it will attract negative charge and repel the positive charge. So in one sphere, the negative charge will be created, and the other sphere, the positive charge will be created. If we bring the positive rod near the spheres, as I explained you in my earlier lecture, conduction, how the charges are developed by the process of conduction. So if we bring the positive charge near to the two spheres, right, they are both attached close to each other. So in a sphere, we found if we bring the positive charge in A spheres, that this positive rod will attract the negative charge in A sphere and repel the positive charge. And in A, we have a negative charge created, and in sphere B, we will create the positive charge. Same thing will happen over here. So if we bring the positive charge, you can see if you bring the positive charge, positive rod near the sphere, near this sphere, so this positive charge will attract the negative charge, and in the bottom of the leaves, the positive charge will be developed. If we bring the negative rod, so it will attract the positive, and on the leaves, the positive charge will be created. But if we bring the negative rod, it will attract the positive charge, and in the leaves we have the negative charge, right? So you know the property is that when the two leaves have the negative charge, so they are the like charges. So you know the like charges repel each other. I explain. I explain one more time. This is the neutral body, and there is no charge in the body. When we bring the positive rod near to the disk, this is the disk, okay? So if we bring the positive charge, positive rod near the disk, what will happen? The positive will be a positive in the rod will be attracted with the negative. So on the disc we have the negative charge, and on the rod, on these leaves we have a negative charge. Okay, if there are the positive charges over here, the negative will be here. If there is a negative on the disc, then positive will be on the plates, on the leaves. Okay, so like charges, they repel, and these two leaves have negative charge, so they will be repelled. So by the repulsion, the divergence will be created. They will be move away from each other. Okay, so that's why they have opened a little bit, because they are repelling each other. Okay, so this electroscope is used to for the detection of the charge. So the detection of the charge, now if we bring the negative rod over here, the positive rod, it will attract the positive, and then on the disc we have the positive, and on the leaf we have the negative. If we bring the positive here, it will attract the negative over here. So positive will be over here on the leaves, so they will be repelled. So like charges repel each other. Okay. So now all this however here, if they have said all things on here what I explained to you. Electroscope can be charged by the process of electrostatic induction. This is the process of electrostatic, because induction we are bringing the positive rod or negative rod near. This is called the electrostatic induction, as we discussed in our last lecture. In order to produce positive charge in the electroscope, bring a negatively charged body near the disc. If of the electroscope, figure 13.8, you can see in a positive charge will appear on the disc of the electroscope, while negative charge will shift to the leads. I already have explained to you. Now connect the disc of the electroscope to the earth's aluminum foil by conducting the wire 13.8. This is the earth wire, right? To earth's aluminum foil by connecting the wire 13.8B. The earth of the leaf will flow to the earth through the wire. If we first break the earth connection and then remove the rod, the electroscope will be left with positive charge. Okay, if we remove this, so the electroscope will be if we don't have this earth connection, then the charge will develop on the electroscope and it will not go anywhere. So if we remove this one, so all the charge over here, it will be grounded. It will be grounded. It will go to the ground, and there will be no charge left. But if we don't have this ground space, the charge will be left on the disc or over here or on the leads. So this is how we can say that the electroscope is used for the detection of the charge by the process of electrostatic induction, as we discussed in lecture, in my last lecture. Now, electroscope electroscope can also be type of charge, detection of type of charge, what type of charge it has. Detection of type of charge, for the detection of type of, it is also used for the detection of type of charge, whether it carries a positive charge or whether it carries a negative charge. Okay. For the detection of the type of charge on the body, electroscope first charge either positively or negatively. So in order for the detect, this is also used for the detection of the type of charge. It will tell you what type of charge it has. It has positive charge or negative charge. For example, suppose the electroscope is positively charged, as explained before, 13.8. Now, in order to detect the type of charge on our body, bring the charged body near the disk of the positively charged electroscope. If the divergence of the leads increases, the body carries. If the divergence is increases like this, if the divergence has been increases, it means it carries positive charge. On the other hand, if the divergence decreases, the body has negative. Suppose if it is not opening here, it is opening a lot. It means it has a positive charge carry. But if it is not opening like this, it is opening like this, it has a negative charge. Okay. So if the divergence is more, then it carries positive charge. If the divergence is less, it carries negative charge. So identify conductor and insulator. It can also be used. Electroscope can also be used for detection of the um, for the whether it is a conductor or insulator. Where the electricity or heat can pass through, it is called conductor. Where these two things cannot pass through, so that is called insulator. Conductors like copper, this is the conductor. Steel is a conductor. Insulator is rubber is an insulator, wood is an insulator. So it is also used for the detection of the conductor and whether it is a conductor or insulator. So we study now. Electroscope can also be used for the distinguish between insulator and conductor. Touch the disc of the charged electroscope with the material under test. So this, if we touch that, this is a disc, okay. So if we touch the disc with the material under test, disk of charged electroscope with material under test. If the leaves collapse from their diverged position, from their, if they are here, if they collapse, if they close down a little bit, it's mean if there is no charge, is a good conductor. If from their divergence, if they have the divergence over here, if we bring the charge, uh, touch the disk of the charge electroscope with the material in the test, if the leaves collapse from their diverged position, this is the diverged position. If they collapse, if they move a little bit, then they are the conductor. If there is no charge on the divergence of the leaf, it will show that the body and the test is an insulator. If they don't diverge, if they remain at its own position, then it means they have the material and the test is insulator. So three things we discussed in this. First of all, we discussed about electroscope. Electroscope is a sensitive instrument for the detection of the charges. Then what it consists of, it has a brass rod, it has a brass disc, insulator, and leaves, and one is grounded, and all the things are enclosed in a jar, glass jar. So these two things are very important, glass disc and the leaves, because if there is a charge over here, if there is a positive charge over here, the negative charge will be appear on the leaf. If there is a negative charge over here on the disc, then the positive charge will be on the leaves. So you know the property that the two like charges repel each other. If the positive charge on the leaves, they will repel each other. If the negative charge on the both the leaves, they will be repel each other. So electroscope can also be used. Electroscope can also be used to detect type of charges, whether it has positive charge or negative charge, which I told you. And it also can also be used whether the material is conductor or insulator. I told you what is conductor and insulator. Conductors in which the heat and electricity can pass through, and insulator where heat and electricity cannot pass through. So rubber is an example, wood is an example of insulator, conductors is steel, gold, copper, these are conductors, okay. So this electroscope can also be used to find whether the material is conductor or insulator. Now I'm moving towards my next topic, which is 13.4, and 13.4 is Coulomb's law. What is Coulomb's law? Coulomb is the name of the scientist, okay. We know that the force of attraction or repulsion acts between two charged bodies. Two charged bodies, if there is a unlike charges, there will be the attraction, and if there is a like charges, the repulsion will be occur, because two like charges repel each other and two unlike charges attract each other. If one body has positive charge and one body has negative charge, there will be the attraction. And if one body has positive charge, another body has also positive charge, they are the like charges, they will repel each other. If one body has negative charge, another body has negative charge, so they are like charges, they will repel each other as well. So there was an French scientist whose name was Charles Coulomb in 1736, 1806, 1736 to 1806. In 1785, experimentally established Charles Coulomb, a French scientist. The name of the Coulomb is a French. Coulomb was a French scientist. A French scientist, Charles Coulomb, 1876, 1736 to 1806. In 1870, 1785, experimentally established the fundamental law of electric force between two stationary charged particles. Because we are studying the electrostatic, we are studying the static electricity. We are not studying the moving electricity. We are studying the static electricity. Static electricity means charges at rest. Charges at rest. So I told you in my earlier lecture, when we in a comb, when we rub the comb, the charges there are the charges at rest. So they will start attracting after rubbing in my hair. They will start attracting the small pieces of paper. So in this example, uh, electrostatic charges at rest. We are in this chapter. We are studying the charges at rest. So he said the French scientist whose name was Charles Coulomb. He experimentally established the law, which is called the an electric force between there is an electric force between two stationary charged particles exist. Okay. The next is he stated the statement of the Coulomb's law is the statement of the Coulomb's law is the force of attraction or repulsion between the 2 point charges is directly proportional to the product of their magnitude of the charges and inversely proportional to the square of the distance between them. So you know this there is a if there is a like charges they will repel. If they are unlike charges they will attract. Okay. So he is saying the force of attraction or repulsion. If there are the like charges, the repulsion will occur. If they are unlike charges, the attraction will occur. The force of attraction or repulsion between 2 point charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. Suppose there are the two point charges. Let first point charge is noted with Q1 and the other point charge is noted with Q2 because force of attraction and repulsion exists between 2 point charges. Product means the product of their and the force of repulsion and attraction will exist is directly proportional to the product of their 2 point charges. You can see Q1 and Q2. These are the product of the point charges. The force of if there is a if they are the like charges, if Q1 and Q2 are the like charges, it means repulsion will occur because like charges repel each other. If there is a Q1 and Q2 are one has positive charge and one has negative charge, so it means force of attraction will exist. So for the force of attraction and the repulsion uh, exist is directly proportional to the product of their point charges and force of attraction is inversely proportional to the square of the distance between them. If there is a more square, if the distance is more, the force will be less. If the distance is less, the force is more. It means if the point charges are close to each other, the force of attraction will be more. If the point of charges are far away from each other, the force of attraction will be less. A force of attraction or repulsion will be less. So he has developed the two equations. First, the force of attraction and repulsion is directly proportional to the product of their point charges, and force of attraction and repulsion is inversely because r is in at the bottom is 1/r square. It means force of attraction is inversely proportional to the square of the distance. If we combine equation number 13.1 and 13.2, the left hand side are equal, the right hand side will be equal to. So F equals to Q1 Q2 divided by R square. The formula will be if we combine these 13.1 and 13.2, he has written combining equation 13.1 and 13.2. You can get you there is one more step comes before this, which will be F is directly proportional to the Q1 divided by Q2 divided by R square. If you remove a directly proportional sign, it means the constant of proportionality K and some equal signs will come, as we have discussed in ninth class. So whenever we remove the directly proportional sign, so this proportional sign, two things will come, equal and some constant of proportionality. So when we combine this the one more equation will come. F is directly proportional to Q1 Q2. This will come on the top and R scale will become on the bottom. Q1 Q2 divided by R scale. F is directly proportional to Q1 Q2 divided by R scale. If we remove the inverse proportion sign, so two things will come, equal and constant of proportionality, and Q1 Q2 divided by R scale. This is known as 13.3 is known as Coulomb's law. What is F? What is Q? What is Q2? Now I'm going to explain you where F is a force between two charges and is called the Coulomb force. This force is called the Coulomb force. Where Q1, Q2 are the magnitude of the two charges. These are the 2 point charges. Okay. and r is the distance between the two charges. So if they have more distance, the force will be less. If they have less distance, the force will be more. So r is the distance between these two point charges where they have been placed, where the point charges are, they are more apart from each other or they are very close to each other. What is K? K is the constant of proportionality. Where K is the constant of proportionality, the value of K depends on medium between the two point charges. If there is an air between two point charges, the medium is, if the air is medium, so if they are placed in a vacuum, so our medium will be different. If it has a air, so the medium will be air. So in this, it depends upon the value of K depends upon the medium between the two point charges. If the medium between the two point charge is air, then the value of K is in SI unit will be 9 into 10 power 9 Newton meter square per Coulomb square. We got to memorize this value because value of K when the medium between these two point charges is K and K is uh, air, air between these two point charges, then our value of K in SI is 9 into 10 power 9 Newton per meter square per Coulomb square. This is very important. The value if the medium of the two charges is air, if the Q1 and Q2, if the air is between Q1 and Q2, then the value of constant of proportionality K in SI will be 9 into 10 to the power 9 Newton meter square per Coulomb square. Coulomb's law true only for point charges whose size are very small as compared to the distance between them. So Coulomb's law is only valid for the 2 point charges. It is not for the bigger charges. It is only hold for the point charges where when the two charges are very small. When the two charges are very small, the Coulomb's law will be hold. Q1, Q2 are point charges and they are very less. It is not valid for the bigger charges. Now I am going to solve the example, and the example is 13.1 on page number 74. Please open page number 74. I am going to apply the Coulomb's law. By applying the Coulomb's law, I am going to solve example 13.1. I read the example statement first. Two bodies are oppositely charged with 500 microcoulomb and 100 microcoulomb charge. Find the force between the two charges if the distance between them is in air is 0.5 meter. I repeat, two bodies are oppositely charged with 500 micro. Mu mean micro coulomb and the unit of charge is coulomb. Since it is a small unit, that's why I'm writing micro coulomb. 500 microcoulomb and 100 microcoulomb. It means Q1 is 500 microcoulomb and Q2 is second point charge is 100 microcoulomb. And R is the distance between these 2 point charge is given to me. R is given to me 0.5 meter. And the unit of distance is meter. And the unit of charges is coulomb. And since these are the micro charges, it means they are small charges. That's why they are written micro coulomb. The basic unit, SI unit of the charge is coulomb, but here these are the small units, so that's why micro coulomb. So first of all, we need to convert this in SI, which is called coulomb. So I will multiply 500 multiply by 10 to the power minus 6. You know micro is 10 to the power minus 6. And 100 microcoulomb and micro is 100 times power minus 6 again. First of all, I need to convert this into coulomb because SI unit of the charge is coulomb. Small microcoulomb is a smaller unit. That's why we need to convert this into coulomb, which is the SI unit. So similarly, R is given to me in centimeter. The unit of distance between 2 point charges is already in SI unit, so we don't need to convert this into any other unit. So meter is the standard unit, SI unit of the distance. I will use the formula and the Coulomb's law. This is called the Coulomb's law. F is equal to K Q1 Q2 divided by R square. As I just solve this, we derive this 13.3. F is equal to K Q1 Q2 divided by R square. I'm going to use this formula to find the Coulomb force or force between these 2 point charges. So I will use this formula. F is equal to K. K is the constant of proportionality. Q1, Q2 are the 2 point charges, and R is the distance between 2 point charges. So Coulomb's law states that the product of 2 point charges, force between the two product of 2 point charges directly proportional to the magnitude of their magnitude of the product of the 2 point charges inversely to the scale of the distance between them. So no, I'm just plugging the values. You know the value. If the air medium is air, the K will be the value of K will be, I told you, 9 into 10 power 9 Newton meter square per coulomb square. And Q1, you know, value of Q1 is 500, which is 500 into 10 power. Q1 is 500 into 10 power minus 6. And Q2 is 100 into 10 power minus 6. I told you, you need to convert this into SI. And the SI unit of charge is coulomb. Now just put these values into this. The K value is 9 into 10 power 6. Q1 is 500 multiplied by 10 power minus 6. And Q2 is 100 into 10 power minus 6. First of all, the easiest way to solve this 10 powers um, by solving the tens powers separately. You just need to multiply 500 multiplied by 9. Then basically the same power will be added. Use this principle, solve this one, and then 0.5 whole square and divide this. You can solve this with the help of the calculator. By using the calculator, you will find the force of attraction will be 1800 Newton. And the unit of force of attraction is Newton. And the force unit is Newton. So our force between these 2 point charges is found to be force is 1800 Newton. So students, this is the end of the our topic. Today's topic 13.3 and 13.4. I hope you all understand these topics very well. If you still have any query, any question regarding today's topic, please let me know. Feel free to ask questions. Please unmute your mic, ask questions. Thank you. Yes, please. Habibullah, Fatima, Ahmad Shamsi, if you still have any questions regarding today's topic, please feel free to ask questions. And your homework is this is your homework. Please memorize the topic covered in today's lecture and write them down once. You need to write them down on the rough register. I won't check the rough register. I will check only the neat register. Your the problems which we do at the end of the chapter. I will check only those things. But for your practice, you need to practice what the lectures we covered today. You need to memorize this and then write them down. The numericals involved in this chapter, please try to solve them as well, because please practice them side by side. It will be very convenient for you. But if you keep on lingering on, it means that will be a problem for you at the end of when the examination will start.